Good afternoon, everyone. Welcome to IPDay's Webinar Wednesdays. I'm June Rawl, your IPDay Director. On behalf of IPDay and the Florida Department of Education, we want to personally thank all of you for making the commitment to join this webinar today. We appreciate and applaud the incredible work you do each and every day to assist students with the knowledge and skills they need to pass the GED test and move into post-secondary education and career training. We've heard that many of you are joining us today in groups and have planned your PD planning time around these webinars. Thank you. Today's webinar, Math DefragGED GED Problem Solving, will help prepare your students to be effective problem solvers and be ready for the math portion of the GED test. Today, we will discuss a simplified problem-solving framework that you can use with your students. We will identify mathematical practices to apply while solving word problems, and we will provide a battery of word problems that reflect the content and the rigor of the 2014 GED test. You can use these samples to test your students' knowledge. The webinar today is facilitated by no stranger to all of us in adult ed. Ronald Cruz, Administrative Coordinator of the Caribbean Refugee Program at Hillsborough County Public Schools. You may recognize Ron as he led us through some instrumental workshops in 2014. We appreciate his depth of knowledge and his passion for adult education. I encourage you to ask a lot of questions today and engage in the webinar. We welcome your feedback and we would love to hear from you. You can do this by entering your questions in the chat bar. With that, I will turn the webinar over to Ronald Cruz. Assisting Ron today is Lynn Ralston, also from Hillsborough County Public Schools. Enjoy the webinar. Ron?
Thank you, June. Thank you, everyone, for spending precious time within your day to participate in today's webinar. This webinar is created due to the fact that there is many feedback from our workshops throughout the state that they needed more ways or samples or models of problem-solving techniques and problem-solving framework that they can use with their students. So with that said, we're going to focus on this particular need that was voiced out by the teachers, and hopefully you will gain a lot of information and skills from this webinar. I just wanted to remind you all that this webinar is recorded, so don't feel like you have to write down every single note or whatnot. We will be broadcasting this, and we will be recording this webinar and posting it on the IPDay website so you can view them at a later time, or if you like the webinar so much, you can share them with your colleagues that didn't have the opportunity to join us this afternoon. First, again, I'd like to introduce myself. My name is Ron Cruz, Administrative Coordinator at the Caribbean Refugee Program, Hillsborough County Public Schools. And here are just some of the things that I've done within my experience in education. Now, we will start by engaging you all and asking your feedback. I'd like for you to use your chat bar and answer the question below that is on your screen. What are some good techniques in real-world problem solving that you know or you use with your students? So I'm going to give you some time to use the chat bar and type in some of the responses. I see one, deductive reasoning. Drawing a diagram. Those are really excellent strategies, very important for our students. I see visual aids, which is very similar to drawing a picture in a diagram. reading just a little of the question and writing notes so important for our students, because some of them, the first time they read the problem, they don't quite understand what the problem is asking for. One of the things I do suggest to my students when we're doing a word problem activity is to read the problem twice, and if possible, can they restate the problem in their own words. Planning, I see somebody typed in planning, very important. You have to have a strategy. A lot of students nowadays are immediately jumping into the equation without fully understanding the salient attributes of a particular scenario. That is so important that we have to plan before we jump right into the equation and the computation and the problem. Oh, I see something that's really good here. Backwards thinking. Backwards thinking is so important. It's another term for that is working backwards. So important when students finish working out their problem, they can start with their answer and then work backwards, see if it really fits the scenario or if it really addresses the problem at hand. Simplifying numbers and technique, drawing a mental picture. These are all great. Keep them coming as Lynn is taking notes of some of these really good strategies that you have. And so I'm gonna put your attention back into our screen again. So just in recap, these are some of the popular problem-solving strategies. You may have heard of them before: illustrating the problem, guess and check. Some students, we don't expect them to be able to know every strategy out there for every single type of word problem. Guess and check works very well with the students. What's so important about that is that students have to be computationally fluent, or they have to be mathematically savvy in order to be able to do the guess and check, meaning their foundations in the basic operations and basic skills have to be very, very strong. Simplifying the problem is another good technique. Sometimes the problem is clouded out with many unnecessary information that students will not use to arrive at the correct answer. Sometimes students are able to get the correct answer or arrive at an answer to a problem-solving scenario just by looking for patterns in numbers, and that's also another way, and it's also a good test-taking strategy. When the problem is too big, one of the things that I suggest to my students is breaking it down into smaller pieces. Start with are there information that is missing in a problem that I have to solve for first before I jump into what really is the problem asking for. This works hand in hand with the plan. And again, here it is, it's working backwards. Working backwards is another important step that students need to do, even though they've already finished solving the problem. It's always a good practice to look back and see if is it reasonable. I would like to draw your attention to a framework that has been emphasized in our assessment guide when the 2014 GED standards or the GED test came out. When they rolled that out, one of the things that is in the assessment guide is Polya's four-step problem-solving approach. I find this very important, and I'm very happy that GED testing service provided educators with this piece of information. To me, it's a very simple plan. It's a very simple framework where students can easily follow these steps. So to ensure that they are really solving the problem with fidelity. Starting with the understand portion. Students need to understand the problem. What is being asked? What is all that is given? If necessary, they may have to sort out which information is important and which information is not important. Sometimes there will be some missing information, and that's part of, again, understanding the problem. And if you have some missing information, students will have to find a way to derive the information one way or another. We go to the second step of Polya's problem-solving approach, which is the plan portion. This is where students have to identify what strategy do they have to use. Do they have to work backwards? Do they have to complete a pattern? Do they have to write an equation? Would a graph be necessary? Those are the types of things that students now start to ask themselves at this stage of the problem-solving approach. The next step would be the solve portion. The solve step of the problem is simply just carrying out the plans, carrying out the strategy, solving the equation for the unknown, or completing the graph, or from the graph deriving an equation to make a prediction. Those are the types of things that happen under the solve portion of the four-step problem-solving approach. And then lastly is the check. I know that this is, students, this is the most disregarded step in the problem-solving approach, and I cannot underestimate this step so much because students will have to really check. I know that the GED test is a time test, but it only takes a second to double check whether they really are addressing the problem, because the GED tests have really very strong distractors that will kind of give the student the impression that they have the correct answer, but it's not. So one of the things that students should ask is the answer reasonable? Can I use the dimensions? Okay, are my units matching? Okay, are they giving are all the given information in feet that I have to convert in inches later on? Sometimes students will have to work backwards to do that. And then again, revisiting the problem, reading that main question that the problem is asking and making sure that it makes sense. One of the teachers that I've encountered in the field, shared with me a strategy that she implemented in her class. What she does is once the student finishes solving a problem, she asks the students to write a statement relating the answer back to the question. And I think that's an excellent, excellent strategy that was shared by that teacher. So I started implementing it with my students, and it worked wonders. It really forces them to revisit the problem. Now, I also wanted to go over another important piece in the GED standards, or the GED 2014 GED Mathematics Reasoning module. They started off with talking about the mathematical practices. So I want to go over these mathematical practices again, and then I'm going to explain to you how all of these practices fit into the Polya's four-step problem-solving approach. So first of all, building solution pathways and lines of reasoning. This is where the students have to develop the plan in the problem-solving approach. Second is abstracting problems. Abstracting problems, students are supposed to be able to efficiently and quickly be able to translate between words and symbols, or vice versa, or creating an equation based on a specific scenario, or it could be an inequality. Furthering lines of reasoning is that in certain problems in the mathematics reasoning module, using the same equation to derive an answer for the next question. And that's just a demonstration of furthering the lines of reasoning. Take, for example, let's say you came up with an equation already from the previous question. They will revisit that equation again and use that answer to, as a tool or as a means to find the answer for the next question. Another one is mathematical fluency. So this is where all your basic computation skills fall into. Simplifying fractions, finding the percentage of a particular number, converting between mixed numbers to improper fractions. Those are the skills that students need to keep enhancing and practicing on a daily basis so that this fluency does not get in the way of their problem solving. And lastly is evaluating reasoning and solution pathways. So as I was going through these mathematical practices, I'm sure you're already hearing about or kind of reminiscing that the four-step problem-solving approach. So here's I'm going to show you how they all fit together. So here again is the 4-step problem-solving approach that we had in the previous slide. Now, where all of the popular techniques in solving problems, they fall under the plan and solve. They fall somewhere in between those 2 steps. Illustrating the problem, guess and check, all of those things fall in between the planning and the solving of the 4-step approach. The building of solution pathways and lines of reasoning, that happens at the beginning stages of the problem-solving approach, on the understand and the planning. How am I going to solve this problem? What type of strategy do I have to use? Do I have to find out anything that is missing in terms of information? And then when they have a full grasp of the problem, that's when they can now start abstracting the problem, meaning taking the real-world situation and putting it into an equation, and then eventually solving that equation. Furthering lines of reasoning is another mathematical practice, and it falls under the solve step. That's when students have to look into their solution and see, okay, is this the final answer, or do I have to use this answer to come up with the ultimate answer for this question? And then lastly, oh, not yet, we still have mathematical fluency. I forgot to mention, mathematical fluency exists throughout all of the stages. So in terms of concept, in terms of conversion between units, writing fractions into decimals, or converting mixed numbers, those fluency techniques happen throughout. It could start in the understanding portion. It could start on the planning portion, or even in the solve portion. Definitely fluency will fall under all of the 4 steps of the approach. And lastly, evaluating lines of reasoning and solution pathways, that falls under the check portion of the problem-solving approach. So now you see how they all kind of fit together. You know, they all kind of mean similar to each other, and now we have a working framework as to how we're going to solve these problems, these word problems that is that creates a high level of anxiety in terms of with our students. Okay, so we're going to go ahead and get started with solving and modeling the use of this framework in solving a sample word problem. So we have 4 sample word problems in this particular webinar. So the first one is a word problem focusing on geometry. So I'm going to give you some time to read the problem and try to understand the problem. So now I'm going to switch view. Don't worry, the problem will still be posted. I'm just going to switch view and go to my notes so I can start solving this this problem with you. All right. So what I'm going to do is I'm going to read the problem and then just to give you a little bit more time to understand it. During a catering event, a chef is trying to place as many serving dishes on a buffet table as possible. What is the maximum number of circular serving dishes that the chef can fit on a 4 by 8 foot rectangular table if all serving dishes have a radius of 6 inches? And they gave us an extra piece of information here. Use pi equals 3.14. So now, when we start solving this problem, some of my students, I could already tell you, they're going to immediately look for the equation or the formula for the area of a circle because they know that the plate is circular and they're giving us area. I mean, they're giving us the area of the rectangular table, which is a 4 by 8 foot in area. And then they gave us the value of pi. But what you really need to focus on is that this problem and the area formula is really not necessary. So what I would suggest for my students is really start to draw the problem first. So I'm going to start by drawing the problem. So first, I'm going to draw a corner of the table. I'm not going to complete the table yet, but I'm just going to draw a corner of the table just to start my thinking process with my students. And I'm also going to draw the plate. Okay, and then I'm going to draw in the information that is given. It gave us the radius of 6 inches. Okay, now that I have that information, I'm going to derive other pieces of information from this piece. I can now determine that also based on that information, based on that information, I can also determine that the diameter now is 2 times the radius, which is 2 times 6 equals 12 inches. Now that you know, so I can now start drawing that plate right here. And I know that is 12 inches. And look, I am looking at this piece of information in inches, but my problem is giving me information in feet. So it would also be nice if I can convert 12 inches to feet. So this problem easily works that out for us. 12 inches is equal to 1 foot. So now I know that the plate spans a foot across, and also it spans a foot going up and down. And then, so now I can determine how many plates can I put together at this table. So when some of my students will start drawing these, and eventually they'll figure out that if it has a width of 8 feet, they can fit in as many as 8 plates. And then also knowing that the height of the table is, the width of the table is 4 feet, then they can also draw it that way. So now we can tell, so students can some of my students will continue drawing these plates, but right now some of my students, a majority of my students will see, okay, so now I can just simply multiply how many plates I have going up and down and how many plates I have going across to find out the total number of plates that would fit in the table. So doing that, total number of plates is equal to 4 times 8, which is 32. So now let's see all of the 4 steps on how is the 4 steps carried out in this particular situation. So in this, when I did this portion of the problem and then started drawing it here, that is the understanding planning portion of my problem-solving approach. And then as I carried out the steps, or I continue drawing these plates into the table, 4x8 table, that's your solve portion. And then when I revisited back this 32 and this is number of plates, because I can double check that and see if this really going to be 32 plates that can fit in here. That's an easy way of doing that, and that would be your evaluate portion. Let's try to also identify what mathematical practices did I apply here. So building solution pathways happened right here when I did the understand and the planning portion. My solution pathway is pretty much very visual. I didn't have to do any abstracting of problems here, nor did I have a furthering lines of reasoning, but I did apply evaluating lines of reasoning here. The only mathematical fluency here applied is your multiplication facts, which is 4 times 8. All right. So now, let's go to the next portion, which is our question and answer. So let's look back at that problem that we just solved. I want to give you some time to pose some questions or comments, and then I'm gonna try to entertain some of them. And Lynn is doing a great job, by the way. She's the one that is answering and replying to your questions. So keep them coming because we wanted to address all of your questions. Make sure that you really are getting the most out of this webinar. Okay. And don't worry, after every word problem, we're going to have an opportunity to answer and ask questions. Okay, we're going to move on to the next question. All right. So let me give you some time to read the question. Read silently with me as I read out loud. At 10:30 a.m., the track and field coach asked Taylor and Damien to start warming up by running around the track. Taylor knew he can run at an average rate of 1.5 miles per hour faster than Damien, so he gave him a 30-minute head start. If Damien runs at an average rate of 3.5 miles per hour, complete the prediction below. Taylor will catch up with Damien after blank at around blank. This is a drop-down type of GED question. So we try to incorporate as many different types of GED tests formats so that you can see how some of these problems try to fit in these different problem approaches. So this one is a drop-down where students will have to make a selection between two. This is a much more difficult and a higher level type of question than a multiple choice question. So now we're going to work this out together and see how we're going to attack this problem. So I'm going to go to the next sheet, okay? All right, as you can see, the problem is still posted. Okay, I'm going to scroll down just a little bit so it'll give me enough room to write. All right. So, how will I approach this problem? It's really understanding the problem. Some of my students, I could tell that they would start drawing Taylor, which is the strong Taylor. And then Damien. A little bit arms down because he's less agile than him because he runs slower. So I'm going to put Damien right here. Okay. Now, let's look at what we're going to do. Let's describe their speed or how fast they run. Okay, so immediately there's something in the understanding portion of the problem. The easiest information to pick out here is that this last portion right here. where Damien runs at an average rate of 3.5 miles per hour. So I'm going to write down the rate for Damien as 3.5 miles per hour. And then I'm also going to do the same thing for Taylor, but wait a minute. If you look at it, they didn't give out right away exactly how fast Taylor is running. They only gave us a piece of that information, and we have to derive an additional piece of information for us to really describe Taylor's average rate. It says 1.5 miles per hour faster. That is the key word. Faster than Damien. So that word faster, I usually ask my students, highlight that word, underline that. If you say something is faster, what type of operation do you really need to use in order to describe Taylor's average speed? So most of my students will be able to identify that and say, oh, it's going to be an addition. So then I would put in 3.5, which is miles per hour, which is Damien's speed, and I'm going to add 1.5 miles per hour. And then when you simplify that one, that simply adds up to 5 miles per hour. So remember, we're still on the understand portion of the word problem solving approach. Okay, so now we have to plan. That's a little bit harder. So they're looking at how much time would it take, because I have to select how much time does it take for them before they can, before Taylor can meet up with Damien, and then also determine what time of the day would that be. So in order for me to do that, let me look back to my formula sheet. Let's look at that. Do I have a piece of information that I can use within my formula sheet that would really help me describe what's going on in this particular situation? If you look at the bottom, towards the bottom of that formula sheet, you will see the distance formula, D is equal to RT. I am going to use that piece of information in order to describe what's going on. So let's start off with describing and writing an equation for Damien. Usually, okay, here's what I'm going to do Damien. So for Damien, I know that the distance is equal to RT, and I'm writing all in caps. It really doesn't matter. I can write in small, whatever your student is more comfortable with. D is equal to RT. So Damien's distance would be Damien's speed, which is 3.5 miles per hour, multiply that by T. But I don't know what time. That's what I'm looking for. That's really what I'm trying to select here, is the time and the time of the day. So let's continue. So let's look at now, Taylor now. Taylor, using the same distance formula, I can rewrite Taylor as 5 miles per hour multiplied by T. Okay, so we're getting somewhere. Now, how does this 30-minute head start factor into this problem? I usually tell my students, you have to start with whoever started in the situation, whoever started running first. So that means that's Damien. Damien started running first. He had a 30-minute head start. So that means I can modify this time over here to match the situation. Because really and truly, they didn't have the same amount of time to run. Damien had more time to run. So we're going to replace this T. So what I'm going to do is I'm going to change that and erase that T. Okay. I put an arrow there so I remember I have to put something there. So now I'm going to write now the t. Since there is a 30-minute head start, I'm going to add t plus 30 minutes. But wait a minute. Look at that. Now I have created a disconnect between the units. This is in hours and this is in minutes. So what I do and tell my students when I catch this one is I tell them immediately, look at your units. Does that, you cannot have too many units or different units within an equation. So you want to try to convert that to something that is similar. So everything has to be the same units within the equation. So I'm going to go ahead and change that 30 minutes, and students can easily do that on top of their head, mental math, that 30 minutes is half an hour or 0.5 of an hour. So now we have the same units for all. Now, I really don't have to modify Taylor's time because Taylor just had the time that he didn't get any extra time. So let's look at that. So now we're going to go to the planning now. So all of that is just on the understanding portion. Now we're going to start planning. So let's plan. The plan is for them to meet in this particular situation. They are going to meet, and this is what I tell my students when they encounter these types of problems. People, when they meet, that means they have traveled the same distance. So meaning this D right here and this D right here, the Taylor's D and Damien's D have to be equal. But this D's also equate to two different equations. So that means if these two are equal, I can write a whole equation combining Damien and Taylor's together. They have to be the same. 3.5, I'm going to write Damien's first, take 3.5, and I'm just going to remove the units now, so just to simplify my solution. T plus 0.5 hours. Forgot the 0 over there, sorry. And then that is equal to the distance that also Taylor has traveled, so which is 5 times T. And then this now becomes now an algebraic problem. Okay, so let me scroll down a little bit. Give me some room here. Okay, so now that's the planning, and now we're going to go to the solve portion. Okay, usually the solve part is the easy part. It's the planning and the understanding that is the most difficult because they're key to getting the problem right. So now, and here if I see something like this, my students automatically do something like that. They are trained by heart to know and to apply distributive property. So 3.5t plus 0.5 times 3.5. I mean, no, hold on. Let me write that correctly. Sorry about that. 3.5t plus 3.5. My pen is a little acting up, a little crazy. Hold on. 3.5 times 0.5 equals 5t. All right. Now let's multiply these together. 3.5t. Oh, now I'm writing in small. Plus 3.5 times 0.5, that's 1.75. And that's equal to 5t. And then it only gets easier from this point. All right, so from this point we just have to subtract 3.5t. I don't want you to get confused with my conventions with the capital letter. All right, so these cancel out. They come out to 0. We just simply bring this down. 1.75 equals 5 minus 3.5 equals 1.5t. And in order to get t, we just divide both sides by 1.5. And t now is equal to 1.16. No, it's not. It's not 1.7. It is 1.7. Okay. All right. Now we look at this. What does this mean? Now we're going to go to the evaluate portion, and I'm going to go move over here to this side and do the evaluate here. This is now where it becomes really critical that students understand exactly what they've got. What they've got is t is equal to 1.16 hours. Now you ask your students, does that mean 1 hour and 16 minutes? Surely not. We need to still convert that 0.16 of an hour into minutes so that we really see how much time needed. Because if you look back up into what is given, they're giving us in terms of hours and minutes. Okay? So let's go back to our solution below. Now we have to convert that, and that's easily done. What we do is we just simply multiply 0.16, multiply it by 60 minutes. Okay? And if you do that, you're going to get about 9.6 minutes. Okay, so that's right about 10 minutes. So really, it's 1 hour and 10 minutes. So we can even write it as an equation. 1.16 hours is equal to 1 hour and 10 minutes. So that gives us our first answer. Now we got to figure out what time will they meet. So what time in the day would they meet? So the start time is 10:30 a.m. And then let's do this step by step. You know, some students can do this immediately in their head if they're used to a lot of elapsed time problems. But I'm going to model it like step by step. Let me add an hour first, and that will be 11 a.m. So I've already added that hour, and then I'm going to add 10 minutes. So that's going to be written like this. Oh, no, 30, I'm sorry. Okay, so now it's 11:40. And that's the exact time that, well, that's right about the time that when they're going to meet. Remember, we're working with average speed. So Taylor and Damien could be running a little bit faster or slower throughout their run. So if we go to this, to go back to our question, our selection from the drop-down is going to be an hour and 10 minutes and 11:40 a.m. Okay, so let's look back at your notes, and now we're going to entertain some problems. Some questions from you all. If you have any clarifying questions that you may have. All right, I got a few questions here raised from Lynn that she encountered. First question, this is with regards to the previous problem. So let me go back to that previous problem. All right, going back to this previous problem, students will want to find the area of the plates. How should this be addressed? Exactly. The first time I showed this problem to my students, all of them started pulling out their formula sheets or started writing down the area for the circle. I know that we are talking about the area. That's why I told them you've got to understand the problem first and try to dissuade them from immediately jumping into an equation. because sometimes the problem does not need an equation. It just needs an illustration for them to really understand it. What I show this problem, the perfect way to understand, to combat that in your classroom is to show them problems like these. That if they have to write an equation or use the formula, that there is a high likelihood that they're going to get an incorrect answer because they do not understand completely the salient types of problems. So, what we can do is we can look for some more problems that are like these. They're not tricky. They're straightforward. They seem hard, but not too hard, that type of thing. And then your students will now start to see, okay, so not all problems are the same. Not all problems can be solved with an equation. Yes, there are ratios and proportions. That's another question that Lynn just brought up to me. Let me just quickly go to this question right here, our word problem number 2. Although you're not applying the concept of ratios and proportions, the mere fact that we're talking about rates, an average rate, that is, in fact, under the umbrella of ratios and proportions. So when you do this problem, you're not only writing equations, translating equations to variables, but you're also reinforcing the concepts of ratio and proportion. I've seen some students try to solve this problem using a proportion. My suggestion to the teacher is to make sure that every step of the proportion approach is accurate. So I'm not telling you my solution is the ultimate solution. I'm just giving you one of the ways that you can attack the problem. You may have a better way of solving the problem, just like what was raised here by one of our participants, that ratios and proportion strategy can also be used to solve this problem. Thank you for all those questions. These are all very good questions, and I know that tells me that we are really taking advantage of this workshop. Okay, so if there are no more questions in this particular problem, we're going to move on and try to maximize our time. All right. So this one is a 2-part question. So our problem number 3 and a problem number 4 are 2 parts, and we're going to solve them together. A lot of the GED questions appear like this. In this particular question, it's more of a fill in the blank. So it's a little bit harder. It's a little bit more difficult because students have no indication whether they're doing it correctly or not. The first 2 questions that we've had, students have some type of choice where they can pick what answer they may be. So they may have some errors here and there, minor computational errors, but they can still feel confident because they have some choices in front of them. In this case, they do not have any choice. It's a little bit more difficult. It requires a higher level of thinking. So, okay. So, let's go ahead and solve this problem together. So, I'm going to the next one. All right. All right. Understanding and planning the problem. So, let's look at what's given. So we have Fruitio, a self-serve yogurt store, sells the yogurt by the ounce, plus a 5-cent charge for the cup. Table 1 shows different customers, weights of their yogurt, and the corresponding prices. Write an equation to describe the total cost of any purchase of yogurt at Fruitio. Okay, so knowing anything in business, anything, if you're priced by the ounce, it's going to somewhat show linear. Now they have this automatic weighing machines in yogurt stores that you just put in all your fruits and put in your yogurt, put in all your chocolate and candies in there, and then put it on the weighing scale, and the weighing scale spits out the amount that you have to pay at the register. And that's pretty much what's being modeled here. So, so it's going to be a linear equation. So let's look at our formula sheet and see what equation can we use. So there are several choices for linear equations, but actually not several, but it's just a couple of them. Students can start from the point slope form of the equation of the line right down over here at the bottom, or they can use the slope intercept form of the equation. So again, just like I told you, there's many ways to solve this problem. I'm just going to pick one. So they're really going to need, I want to pick this one, the slope intercept form of the equation. But if you look at that, it has the m there. And students need to understand that m is the slope of the line, which is the one right on top of it. So we're going to need both of them if we're going to effectively use this piece of information. So I'm going to write both the pertinent equations. Y equals mx plus b, the slope-intercept form of a line. And then I know that my m is equal to y2 minus y1 over x2 minus x1. So now the problem lies is that which is my y's and which ones is my x's. So again, one way to tell is that usually we assign x as the independent variable, and my y is the dependent variable. So what really controls the price is really how much you put in the cup. So really the independent variable here is your weight, and your dependent variable is none other than your price. So I'm going to label that, and then I just pick two values, data values from each one. The good thing about the slope formula is you can pick any two. You can pick the first two, the first and last, the last two. It really doesn't matter. For the purposes of this, I'm going to pick these two for my y1 and y2. I'm going to pick these other two for my x2 and my x1. All right, and then we just simply plug in the problem. So this is going to be my 2 and my 1 and my 2 and my 1. So, and then that would be m equals, let's just go ahead and plug that into our equation. Substitute that into our equation. 4.25 minus 3.33 divided by 10.5 minus 8.2. Very straightforward subtraction of decimals. All right. So my m, if I simplify the numerator, subtract that, I'm going to get 0.92. And the bottom is 2.3. In this particular question, the calculator button is highlighted on the question. If I post it back later on the, I'll go back to the PowerPoint. But you may allow your students to use the calculator at this point. If you divide these two together, you're going to get 0.4. Okay, one person may ask, okay, I'm going to pause right here and say, why can't I just divide the price by the weight and see how much they're charging me by the ounce? Well, it's not that simple because of this piece of information. They're charging you extra for the cup. Well, some yogurt stores will, some yogurt stores will not. But in this particular case, they do charge for the cup. And if you just simply divide the weight by the price to get the price per ounce, you're not going to get 0.4. You're going to get 0.41, which is a little bit off. But yet, in a fill-in-the-blanks type of question, you're really not going to get it right. So we need to get an exact answer. So now that we have our m, we can now solve for our b. Okay, so we're going to use this m right here and solve for our b. So y is equal to 0.4x plus b. b is our y-intercept. This usually is a harder step for the students if they're not used to solving linear equations. But what I suggest to students is just simply plug in. Pick any value from your table to substitute. Make sure they are substituting appropriately. So let's pick the ones that we haven't used yet. This one for the y, for the x. So that's 0. Y is equal to 3.89 equals 0.4 multiplied by the x, which is right here, 9.6 plus b. If you multiply the 0.4 and the 9.6 together, you're going to get 3.84 plus b right there, and it's equal to 3.89. Just scroll down a little bit. So we do, and then you subtract 3.84 from both sides. This one is going to come out to 0. B is equal to 0.05. Oh, wait a minute. That sounds familiar. 0.05. Isn't that, oh, hold on. I kind of scrolled up too fast here. 0.05, isn't that how much they charge for the cup? Yeah, that is. And if the students do linear problems, real-world modeling problems enough, they will be able to immediately find that out. So if, you know, some of my students are really savvy with linear modeling, they can easily just find out the m, which is 0.4, x and plus b, and knowing this piece of information is being added to the cost. So my students would completely skip this step and just simply plug in 0.05 right here. And they already have the answer. And this is the one that they're going to type in to the blanks as an answer to the question. All right. So let's go back to, so let's look at, let's see some questions here. If you have any questions in this particular problem. I do not understand this question, so I may have to ask Lynn to do an elaboration question. Follow up on that, please. All right. Let's go to, oops, kind of scroll back too fast there. There is one last one, and it's very quick. This one is more of a drag and drop type of question. It's now very straightforward. You're going to use now the information you had from the previous problem to answer this next question. You will know that students are using that same information because the right side of the screen is very similar to the one that's previous. Usually when GED does it, they keep one side of the screen the same, displaying the same piece of information. So let's do this one. All right. So in here, we just simply have to keep up with what our equation, previous equation was. And I'm going to go ahead, and since I've modeled everything already, I can simply just look at this and like, okay, I can use this equation for the price of any yogurt that I purchase at Fruity-O. So if Eric purchases 15 ounces of yogurt, and remember I labeled this X and this is Y, my students will now, oh, I have an X right here, and that can go right there and see what I'm going to get. So 0.4 times 15 plus 0.05. Multiplying these together, you're going to get Y equals 6 plus 0.05. And then you add that together, that's $6.05. So now I'm going to take this number and drag it into that box. Unfortunately, I do not have that capability on my computer since I'm solving it on paper. But students will be able to do that while they're on the test. Okay. So let's entertain some more questions here. Yeah, that's exactly, in here, someone asked, why can't I just do, from the previous question, W times P, weight times the price plus 0.5. Yeah, if you do that, it's not going to be, you're going to be 5 cents over or 5 cents less, depending on how your students quite understand, how they understand the problem. Again, if you divide directly the weight by the price, you're not going to get exactly 40 cents. The problem is structured in a way that there's going to be a significant difference if you do not follow the slope formula. If you want more discussion, you'd like some more discussions about this, we can exchange notes. My email is going to be in here, and you can email me directly, and I'll answer to you in a timely fashion. We can share notes and see how you solve this problem. Maybe we can show an alternative way of solving the problem. Okay, so let's just go ahead and recap this very quickly. We're at the tail end of our webinar, and I understand you all are very busy, but I just wanted to give you some really important parting words. So in order to develop really good problem solving with your students, you wanted to develop certain skills. You want them to know and be able to understand and be able to differentiate between what is essential and what is not essential. They need to be paying attention to details, just like the first problem we solved. You know, the area formula wouldn't really help the students if they had to jump into that area formula for the circle. Abstracting words into equations. Okay, so and vice versa. That's also very important because you know, sometimes it's twice as. Remember that problem with Taylor and Damien running one after the other? You had to be able to quickly translate 1.5 miles per hour faster than. And so you were able to change that. Students must be able to quickly recognize the operation will be addition. Illustration is very important. I tell my students, if you don't understand it, you have to draw it. And sometimes it works wonders for some of my students. Recognizing patterns. Unfortunately, we didn't have some recognizing patterns here. Some slight recognition of patterns on our slope problem with the Fruity Yogurt store. Analyzing data comes in. Students need to know how to read a table. Can they identify which is the dependent and independent variable? Estimation skill is very important. You know, that's also another skill that students need to be enhanced and consistently developed or practiced throughout your daily instruction or throughout the year. How do we increase student anxiety over word problems? Don't wait until the end of the unit to show them a word problem. Start the unit with a word problem or introduce word problems to your students as soon as possible. As soon as they get some type of fluency in the mathematical steps in the processes that you're trying to show, you can start introducing word problems. Use word problems that are relevant, that are real world. If you pick out word problems straight off of the textbook, what I find is a lot of the textbook right now are moving into the real world realm and making it more relevant to the students. So, you know, I would suggest picking and choosing which problems you show to your students. Use the ones that are relevant. When developing computational or procedural fluency, use real-world analogies and representations. You know, so let's say you've got an equation, and just ask the student, okay, if this is an equation, what types of real-world problems can you generate, or situations can you think of that represents this type? And allow them to explore problems before immediately rushing into the algebraic representations. Again, just like I said, prevent students from jumping immediately into writing an equation to represent the problem, because sometimes it does not require that. Teach students how to illustrate word problems or use manipulatives when appropriate. And at the end of the problem-solving process, train them to write a sentence relating the answer back to the question. This one I took from the teacher that I encountered when we were doing the GED workshop throughout the state. Well, if you did like this workshop or webinar, you can, again, go back and review the webinar by visiting the IPDAY website. I also posted there some really important handouts, the PowerPoint slides to go along with the webinar, and also a handout. I developed a handout that you can use and just print out and use in your classroom that mimics, you know, very similar questions that we did today. I also suggest, if you have time, when you review the webinar or using the webinar notes, we will be emailing you a link to complete a survey, an evaluation survey on how much you like or not like this webinar. It would be, your feedback is really important to us so that we can improve and continue to improve our webinar based on what you like and what you don't like. I got some good questions here. Good sources of word problems. Somebody is asking, where can we get these good word problems? I get my word problems everywhere. I have a ton of math books at home. You know, I go into these conferences and they give out these free books, and I just pick and choose. Not one singular book is good. But I use Google a lot. When I'm looking for word problems, there's a ton of word problems out there. They could be solved to you in video format if you look for it in YouTube, or if you just Google it, you'll have plenty of resources. All right. We have a question here, but this one I will make sure that the webinar organizers know and are aware of this question. So we will definitely get back to you soon as we get an answer, because somebody is asking, can anyone get a proof of attendance for this webinar? That is something that we can do. We will definitely send you an email right after this webinar to complete the evaluation. I know I kind of went over 5 minutes over time, but thank you very much for participating, and hope you got a lot from this webinar. Thank you, and email me.